DFS DB file lock. This event occurs only for the DBWR in the parallel server. Each DBWR of every instance holds a global lock on each file in shared mode. The instance that is trying to offline the file will escalate the global lock from shared to exclusive. This signals the other instances to synchronize their SGAs with the control file before the file can be taken offline. The name of this lock is DF, see Appendix B and Q and lock names for more information. DFS lock handle. The session waits for the lock handle of a global lock request. The lock handle identifies a global lock. With this lock handle, other operations can be performed on this global lock to identify the global lock in future operations such as conversions or release. The global lock is maintained by the DLM. PL/SQL lock timer. This event is called through the dimslock.sleep procedure or userlock.sleep procedure. This event will most likely originate from procedures written by a user. SQL*net break/reset to client. The server sends a break or reset message to the client. The session running on the server waits for a reply from the client. SQL*net break/reset to DB link. Same as SQL*net break/reset to client, but in this case, the break/reset message is sent to another server process over a database link. SQL*net message from client. The server process, foreground process, waits for a message from the client process to arrive. SQL*net message from DB link. The session waits while the server process, foreground process, receives messages over a database link from another server process. SQL*net message to client. The server, foreground process, is sending a message to the client. SQL*net message to DB link. The server process, foreground process, is sending a message over a database link to another server process. SQL*net more data from client. The server is performing another send to the client. The previous operation was also a send to the client. SQL*net more data from DB link. The foreground process is expecting more data from a database link. SQL*net more data to client. The server process is sending more data/messages to the client. The previous operation to the client was also a send. SQL*net more data to DB link. The event indicates that the server is sending data over a database link again. The previous operation over this database link was also a send. Buffer busy waits. Wait until a buffer becomes available. This event happens because a buffer is either being read into the buffer cache by another session, and the session is waiting for that read to complete, or the buffer is the buffer cache, but in an incompatible mode, that is, some other session is changing the buffer. Buffer deadlock. Oracle does not really wait on this event, the foreground only yields the CPU. Thus, the chances of catching this event are very low. This is not an application-induced deadlock, but an assumed deadlock by the cache layer. The cache layer cannot get a buffer in a certain mode within a certain amount of time. Buffer for checkpoint. The buffer could not be checkpoint, because some process is modifying it. This means that after the wait, the DBWR will scan the whole buffer cache again. This could happen during a database close or after a user does a local checkpoint. During this situation, the database cannot be closed. Buffer latch. The session waits on the buffer hash chain latch. Primarily used in the dump routines. The index into array of buffer hash chains. When the chain is 0xFFFFFFF, the foreground waits on the LRU latch. Buffer read retry. This event occurs only if the instance is mounted in shared mode, parallel server. During the read of the buffer, the contents changed. This means that either the version number, DBA, or the incarnation and sequence number stored in the block no longer match. The checksum on the block does not match the checksum in the block. The block will be reread, this may fail up to 3 times, then corruption is assumed and the corrupt block is dumped in the trace file. Checkpoint completed. A session waits for a checkpoint to complete. This could happen, for example, during a close database or a local checkpoint. Control file parallel write. This event occurs while the session is writing physical blocks to all control files. This happens when the session starts a control file transaction to make sure that the control files are up to date in case the session crashes before committing the control file transaction. The session commits a transaction to a control file. Changing a generic entry in the control file, the new value is being written to all control files. Wait time. The wait time is the time it takes to finish all writes to all control files. The number of I/O requests which the session wants to write. Control file sequential read. Reading from the control file. This happens in many cases. For example, while making a backup of the control files. Sharing information between instances from the control file. Reading other blocks from the control files. Reading the header block. Control file single write. This wait is signaled while the control file shared information is written to disk. This is an atomic operation protected by an NQ-CF, so that only one session at a time can write to the entire database. Wait time. The wait time is the elapsed time of the write. Conversion file read. This event occurs during the creation of a version 7 control file as part of converting a database to version 7 from version 6. Wait time. The wait time is the elapsed time of the read. DB file parallel read. This happens during recovery. Database blocks that need to be changed as part of recovery are read in parallel from the database. Wait time. Wait until all of the I/OS are completed. DB file parallel write. This event occurs in the DBWR. It indicates that the DBWR is performing a parallel write to files and blocks. The parameter requests indicates the real number of I/OS that are being performed. When the last I/O has gone to disk, the wait ends. Wait time. Wait until all of the I/OS are completed. DB file scattered read. Similar to DB file sequential read, except that the session is reading multiple data blocks. Wait time. The wait time is the actual time it takes to do all of the I/OS. DB file sequential read. The session waits while a sequential read from the database is performed. This event is also used for rebuilding the control file, dumping data file headers, and getting the database file headers. Wait time. The wait time is the actual time it takes to do the I/O. This is the number of blocks that the session is trying to read, should be 1. DB file single write. This event is used to wait for the writing of the file headers. Wait time. The wait time is the actual time it takes to do the I/O. This is the number of blocks that the session is trying to write in file hashtag starting at block hashtag. Direct path read. During direct path operations, the data is asynchronously read from the database files. At some stage, the session needs to make sure that all outstanding asynchronous I/O have been completed to disk. This can also happen if during a direct read no more slots are available to store outstanding load requests. A load request could consist of multiple I/OS. Wait time, 10 seconds. The session will be posted by the completing asynchronous I/O. It will never wait the entire 10 seconds. The session waits in a tight loop until all outstanding I/OS have completed. Direct path write. During direct path operations, the data is asynchronously written to the database files. At some stage, the session needs to make sure that all outstanding asynchronous I/O have been completed to disk. This can also happen if during a direct write no more slots are available to store outstanding load requests. A load request could consist of multiple I/OS. Wait time, 10 seconds. The session will be posted by the completing asynchronous I/O. It will never wait the entire 10 seconds. The session waits in a tight loop until all outstanding I/OS have completed. Dispatcher shutdown. During shutdown immediate or normal, the shutdown process must wait for all the dispatchers to shut down. As each dispatcher is signaled, the session that causes the shutdown waits on this event until the requested dispatcher is no longer alive. Duplicate cluster key. It is possible for a race condition to occur when creating a new cluster key. If it is found that another process has put the cluster key into the data/index block, then the session waits and retries. The retry should then find a valid cluster key. The DBA of the block must look into which the session is trying to insert a cluster key. Enqueue. The session is waiting for a local enqueue. The wait is dependent on the name of the enqueue, see Appendix B, enqueue and lock names. Wait time depends on the enqueue name. Free buffer waits. This will happen if all buffer gets have been suspended. This could happen when a file was read-only and is now read-write. All the existing buffers need to be invalidated since they are not linked to lock elements needed when mounted parallel, shared. So cache buffers are not assigned to data block addresses until the invalidation is finished. The session moved some dirty buffers to the dirty queue and now this dirty queue is full. The dirty queue needs to be written first. The session will wait on this event and try again to find a free buffer. This also happens after inspecting free buffer inspected buffers. If no free buffer is found, Oracle waits for 1 second, and then tries to get the buffer again, depends on the context. For more information, see free buffer inspected on page C8. Free global transaction table entry. The session is waiting for a free slot in the global transaction table, used by the distributed database option. It will wait for 1 second and try again. Free process state object. Used during the creation of a process. The session will scan the process table and look for a free process slot. If none can be found, PMON is posted to check if all the processes currently in the process table are still alive. If there are dead processes, PMON will clean them and make the process slot available to new processes. The waiting process will then rescan the process table to find the new slot. Global cache lock busy. The session waits to convert a buffer up from shared current to exclusive current status. Global cache lock cleanup. PMON is waiting for an LCK process to clean up the lock context after a foreground process died while doing a global cache lock operation. Global cache lock null to S. The session waits for a lock convert from null to shared mode on the block identified by file hashtag and block hashtag. Global cache lock null to X. The session waits for a lock convert from null to exclusive mode on the block identified by file hashtag and block hashtag. Global cache lock open null. The session waits for a lock get in null mode on the block identified by file hashtag and block hashtag. Global cache lock open S. The session waits for a lock get in shared mode on the block identified by file hashtag and block hashtag. Global cache lock open SS. The session waits for a lock get in sub-shared mode on the block identified by file hashtag and block hashtag. Global cache lock open X. The session waits for a lock get in exclusive mode on the block identified by file hashtag and block hashtag.